In this video, I want to talk about Newton's third law. So we've learned Newton's second law told us the amount of acceleration that we get for a certain net force. And Newton's third law is, it gives you another fact about forces, and which is that forces always come in pairs. All right, let's talk about this. Imagine you were applying a force. So you push against the wall, okay? The wall is actually also going to push back on you, all right? The evidence of that is that if you push against the wall, let's say with a certain texture, and you really hard, when you pull your hand back, you will see that your skin will the wall would have pressed into your skin, and so you'll see the texture, the shape, the pattern on your skin, all right? If you, let's say a more dramatic example, let's say you pushed on a knife blade, okay? If you push on a sharp knife blade really hard, you're going to get cut. Why are you cut? You're cut because the blade also pushed on your finger, all right? See how that works? Now, so you always see this. I dare you to think of a situation where there's a force without an equal and opposite force, okay? And you're not going to find one, all right? Or if you do, you're going to be famous because nobody else has found it. So Newton's third law, okay? When an object applies a force to another object, the second object also applies a force to the first object with the same strength but opposite direction. All right, you will see some people will talk about, some people will say this different ways. They'll say for every action there is a reaction. You may have heard that before, where they're calling the first force the action and the equal and opposite force from the other object the reaction, okay? What are some examples of how this might appear in a problem? Well, here's one famous example. Think about firing a gun, okay? So here is a person, and they're going to, let's say that you knew the force, you knew that the bullet had a mass of MB for bullet, let's say it was 0.01 kilograms, and you knew that the gun, you knew that the gun gave the bullet an acceleration of 100 meters per second squared, and let's say that the guy, mg for guy, let's say he has 100 kilogram mass, and doesn't he also get a recoil? If you've ever fired a gun, you know what I'm talking about. You'll definitely feel a force back. That we call that the recoil force, right? And to keep it simple, let's say he was on an icy lake or something. Excuse me, a frozen surface, so there's no friction on him. All right, so what is going to be his acceleration backwards? Okay, well, Newton's law says that the force on the bullet is equal to the force on the guy. At least the magnitudes are, okay? The directions will be different, all right? So that also means that the mass of the bullet times the acceleration of the bullet is equal to the mass of the guy times the acceleration of the guy. All right. Now I'm assuming everything is positive. I'm focusing on the magnitude, not the components. So if you like, you can, if that bothers you, you can put absolute values here, like that. All right. So let's go ahead and solve for the acceleration of the guy. So that's mass of the bullet divided by the mass of the guy times the acceleration of the bullet, positive. So 0.01 divided by 100 times 100 equals 0.01 meters per second squared. Now, you can make you could make a gun with less recoil if you understand this. Think if you had a heavier gun, that would mean that mg is bigger. And so if you work it out, so that means that the denominator in this formula is going to be bigger, which is going to give you a smaller recoil acceleration. Okay? That's one example. Okay? Another example of Newton's third law, think about the space shuttle. I know that with the tanks filled before the space shuttle was decommissioned, I know that it weighed about 2 million newtons. All right? How in the world do we get 2 million newtons off the ground? Okay? So what is keeping it going up? All right? So what's happening, the way rockets work, is they're pushing the rocket fuel, the exhaust, out the bottom, right? And so at high speed, high acceleration. So we know from Newton's third law that's going to cause a equal and opposite force, and so it's the opposite force pushing up on the rocket that moves it up. You see that? Now the gas, the rocket fuel, the gas that's expelled doesn't have that much mass, so you have to make up for it by pushing a lot of it out at really high speed. I happen to know, or I heard somewhere, that when they launched the Saturn rockets, Saturn V rockets that went to the moon, I think they were burning about a swimming pool of fuel a second. That's how much it takes to get all that mass up off the ground. All right. So so basically, keep this in mind. You balance the forces; they're equal and opposite, and you'll be able to solve Newton's third law problems. All right.